In 1958, in the little hamlet of North Lake, Wisconsin, there was an enterprising engineer by the name of John Van Vliet. John's engineering interests led to an interesting variety of unusual hobbies. Among other things, he collected antique outboard motors, flew a helicopter, and built a submarine. Probably on a cold winter day in January, John had a sudden design inspiration for a thread grinder that could produce threads with improved accuracy. Envisioning a great commercial opportunity, John began building the world's first balanced axial thread grinder. The advent of this revolutionary grinder marked the birth of Balax Inc., a company that today utilizes modernized versions of the very thread grinder John Van Vliet invented over 40 years ago. Because of this grinder, Balax is now recognized as the leading manufacturer of cold-forming taps in the cutting tool industry. Balax also manufactures high-quality thread-cutting taps, thread gauges, and roughing end mills. Balax has enjoyed much of its success because of the many advantages offered by a cold-forming tap, which is balanced axially. To understand the importance of a balanced axial design, let's first take a look at the differences between chipless thread forming and thread cutting. Forming and cutting taps create threads that are interchangeable. Therefore, the threads produced by both cutting taps and cold-forming taps gauge in accordance with the industry standards for pitch diameter and minor diameter. The way cutting and forming taps produce threads, however, is completely different. As a cutting tap rotates through a hole, it cuts and removes metal from its path using a series of cutting edges. This cutting action produces metal chips that must either be lifted or pushed out of the hole through flutes in the tap. A thread flower tap produces threads through a progressive cold-forming process. Thread flowers consist of a series of cold-forming lobes or high points on the thread section. These forming lobes are smaller in diameter at the chamfer or lead portion of the tap. The diameter at the chamfer is sized so that the tap freely enters the pre-tap hole and starts on center. From there, each of the cold-forming lobes gradually increases in diameter until they reach the major diameter of the thread that is to be produced by the tap. Since the metal is displaced and is not cut away, no chips are produced. As a result, a forming tap does not require flutes. This basic design difference is also the reason why a forming tap requires a larger pre-tap hole size than a cutting tap. The cutting tap removes material from the wall of the hole, while a cold forming tap displaces or extrudes material to produce a thread. Now, to understand how the balanced axially concept helps the thread forming process, let's compare this thread flower forming tap from Balax with a conventionally ground forming tap from a competitive manufacturer. Notice that the lead crests of the Balax thread flower on the chamfer are the same distance apart from each other as the crests on the body of the tap. The lead crests on the chamfer of the conventional forming tap, on the other hand, are unequally spaced compared to the crests of the tap body. The reason this happens is that conventional thread grinders do not compensate for the variance caused by the taper on the chamfer portion of the tap. Because the Balax thread flower was ground on a Balax thread grinder, the lead threads are on pitch from the start. Why does a balanced axially thread flower tap work better? A conventional forming tap actually cold forms a thread twice, once on the chamfer or lead portion of the tap, as it uses its inaccurate lead thread, and a second time as it moves the thread on pitch. This second tapping effort produces axial thrust on the tap, which increases tapping torque and reduces tap life. With a Balax thread flower, there is no need to make corrections or compensate for an inaccurately formed lead thread. It forms the thread on pitch right from the start. This means there is no axial thrust on the tap. The tap is balanced axially, and the result is up to 30% less tapping torque, longer tap life, and higher tapping speeds. The balanced axial design is a major reason why Balax thread flowers are superior. Now, why should thread flowers be used in many manufacturing applications? In comparison to cutting taps, thread flowers offer 7 important advantages, all of which result in increased production efficiencies and lower tapping costs. The first and probably most important advantage is chipless tapping. The chips that a cutting tab produces create more than just cleanup problems. Chips can cause poor tap lubrication and cooling, tap binding and tap breakage, particularly in deep-threaded holes like this automotive steering wheel component. Chips can also reduce productivity by jamming or clogging the slides and transfer devices of automatic tapping machines. Chips remaining in blind holes after tapping can necessitate costly secondary cleanout operations and lead to product and assembly failure, especially in electrical and hydraulic applications. A second thread flower benefit is longer tap life. The heat and abrasion of thread cutting can quickly dull the sharp cutting edge of a cutting tap. A thread flower doesn't have a cutting edge, but instead has a series of lobes that extrude or press the thread into the metal. The lobes on a thread flower have much more wear surface to produce a thread than does a cutting tap. In many cases, this difference enables thread flowers to last up to 15 times longer than cutting taps under equal conditions. A third thread flower benefit is greater tap strength. Because it has no flutes to weaken the overall structure, a thread flower is stronger than the same size cutting tap. This is particularly important for small taps, where flutes substantially reduce the core diameter of cutting taps. The narrow groove you see in the thread flower is not a flute, but is instead a vent groove. Its purpose is to prevent hydraulic buildup when tapping blind holes. Additional vent grooves on a thread flower will also provide an extra path for lubrication during tapping. The fourth thread flower benefit is faster tapping speeds. There are two reasons for this. First, a thread flower does not concentrate all of its threading action on a fine cutting edge. Instead, it is spread out over the entire surface of the forming lobe. Secondly, the absence of chips minimizes drag and lubrication problems. The combination of these two factors leads to lower heat buildup, which in turn makes faster tapping speeds possible. The fifth thread flower advantage is stronger threads. In materials which work harden, such as steel and stainless steel, the grain flow of the threads formed by a thread flower follows the thread contour, resulting in greater strength. Forming taps provide stronger threads in this high-performance racing engine rocker arm, as well as these die-cast aluminum connecting rods for small gas engines, where heat and vibration is a problem. In stampings, where the thread section is very thin, the added strength of the work-hardened material created by cold forming can be a major improvement to the pull-out strength of the finished part. The sixth thread flower advantage is better thread gauging. Since a thread flower only rearranges metal instead of cutting and removing it, it is much less apt to form oversized threads. This helps increase productivity by reducing scrap. The seventh thread flower advantage is improved CNC tapping. A thread flower guides itself into a hole during tapping because it forms its own lead. This eliminates the tendency to produce drunken or oversized threads due to incorrect feed rates, making thread flowers ideal candidates for non-lead screw tappers, such as CNC machines. Those are the major reasons why many manufacturers have switched to thread flowers. Now, where specifically should thread flowers be used? The general rule is that materials which produce stringy chips are ideal thread forming candidates. Materials which produce powdery chips are often too brittle. All materials that are ductile enough to be extruded or cold formed lend themselves to thread forming. Examples of good forming tap materials include wrought aluminum, screw machine brass, copper, die-cast aluminum, die-cast zinc, and many types of steel and stainless steel. Most screw machine applications require blind hole tapping and use cold forming taps to take advantage of chipless tapping. Examples of tapped screw machine parts include electronic and computer hardware made of mild steel, leaded steel, and 300 series stainless steel. Stamp parts are also excellent thread flower candidates. Materials that can be stamped have ideal mechanical properties for cold form tapping. Some examples include steel oil filter plates, steel, copper, and aluminum electrical parts, steel fasteners used in the automotive industry. Thread flowers also work exceptionally well in zinc and aluminum die-cast parts. The abrasiveness of die castings causes cutting taps to dull quickly, but the forming lobes on a thread flower resist abrasion, resulting in longer tap life. Thread flowers are ideal for high silicone die-cast aluminum parts, die-cast zinc parts, and miniature threads in die-cast computer parts. For those applications where a thread flower forming tap cannot be utilized, Balax has developed a product line of high-performance cutting taps called thread shavers. Thread shaver cutting taps are not balanced axially. However, the Balax thread grinder is used to produce different types of application-specific thread profiles necessary for superior cutting tap performance. Thread shavers are designed to be more consistent, last longer, and produce accurate thread gauging. Thread shavers are made from premium powdered metal tool steel and are fluted using CNC flute grinders or other specialized fluting equipment. Cutting-edge geometries are carefully checked for chip clearance and cutting-edge hook. The Balax thread grinder is then used to produce material-specific relief characteristics for the application required. For example, free cutting materials are best tapped using a stable tap geometry with concentric relief, whereas difficult-to-tap materials are best tapped with an eccentric thread relief profile. Thread shavers are available in different flute configurations to accommodate a variety of applications. Spiral point thread shavers are used for through-hole applications and are available in high hook and low hook geometries. High hook thread shavers are used for stampings and soft to medium hardness materials. Low hook thread shavers are used for harder, more difficult to cut materials. 45-degree spiral flute thread shavers are used for blind holes in steel and stainless steel. The 15-degree slow spiral design helps solve tap breakage problems in harder materials and aerospace alloys due to chip buildup. Balax also stocks thread shavers that are specialized for a given material. Cast iron taps for tapping deep blind holes and through holes, die-cast slow spiral thread shavers for tapping die-cast aluminum and zinc, straight flute dry seal pipe taps for cast iron and die-cast aluminum, and slow spiral tapered pipe taps for materials that produce long stringy chips such as stainless steel. To complement its forming and cutting taps, Balax also manufactures a complete line of taper lock go and no-go thread gauges. These gauges are manufactured and certified by Balax and are available in miniature, machine screw, fractional, and metric sizes. All Balax thread gauges are made from high-speed tool steel for added wear resistance. Each Balax thread gauge comes with a certificate of compliance, which indicates the actual pitch diameter and major diameter of the gauge to a 5-place measurement. Balax thread gauges are also stocked with titanium nitrate coating for maximum wear resistance. Balax has complete in-house manufacturing capabilities in order to guarantee the best possible quality and delivery for its products. Premium quality American-made tool steel is used to make blanks that are turned on CNC lathes or Swiss screw machines. Tap blanks are heat-treated and triple-drawn under controlled conditions. Unlike most of its competitors, Balax has always triple-drawn all of its tools to provide toughness and resistance to breakage. Shank grinding and squaring is completed on high-production, dedicated equipment. Taps and gauges are ground into the finished blanks on balanced axially equipped grinders. Each tool is checked individually for pitch diameter, lead, and critical thread characteristics. Because of its specialization in the field of threading, Balax has developed very broad product lines of thread floor forming taps, thread shaver cutting taps, and thread gauges. Thread floors and thread shavers are stocked with a wide range of standard H and D numbers. Balax maintains a very large inventory of blanks and finished tools in order to offer off-the-shelf delivery for standard tools and short deliveries for special tools. Balax has in-house surface treating facilities that include nitriding, steam oxiding, and 3 types of chrome plating. Balax has test tapping facilities to determine the feasibility of cold form or cut thread tapping in customer-supplied prototype parts. For cold forming taps, Tapping torques, tapping speeds, and different types of lubricants can be evaluated. For cutting taps, chip formation and evacuation can be tested using different flute styles and tap geometries. Because of John Van Vliet and his idea in 1958 for a new thread grinder, Balax today has tools and technology for almost every type of internal threading application. Balax thread floors with their balanced axial design offer chipless tapping, longer tap life, stronger tap design, faster tapping speeds, and better results, including stronger and more accurate threads. Balax thread shavers, designed with application-specific geometries to provide the least cost tapping solution for high-volume applications. Balax thread gauges, precision ground from high-speed tool steel to provide accurate part gauging and long gauge life. Balax, a unique company with a unique thread grinder, providing unique solutions for your tapping and thread gauging applications.